Hello, my dear students. Welcome back. Today we are going to discuss Neet 2026 physics paper. So the paper was it was not easy. It was somewhere between moderate and tough. Let's try to discuss the every single question from this paper. So let's start with the question number one. The question number one is that there are two wires, wire A and wire B. As you can see, there are two wires, wire A and wire B. Okay, the wire A carries a current I and the wire B carries a current which is equal to twice I. The distance between these two wires that is given to you, that's equal H, and linear mass density of wire number A is given, that is lambda. Now what's the question exactly? The question is calculate the value of H. हमें calculate क्या करना है? H such that the wire A is in equilibrium. Equilibrium simply implies that the net force on the wire A should be equal to 0. Okay, the net force on the wire A should be equal to 0. So how many forces are there on the wire A? Obviously there should be two forces on the wire A. One vertically downwards, which is called as weight, another vertically upwards, which is the magnetic force between these two wires. So what I am going to do is that I will balance these two forces. So mg equals to what? Mg equals to the magnetic force. All right, now mg is equal to, what is magnetic force? What's the equation for the magnetic force? That is twice k I1 into I2, which is I, multiplied by twice I multiplied by the length, that's L, divided by the distance between the two, that is H. What we are looking for is this H. So H will be equal to, into 2 is 4, multiplied by K I square L divided by M into G. All right, then we know that this K value is equal to mu naught by 4 pi, which implies 4K is equal to mu naught divided by pi into this I square divided by mass per unit length is lambda. So I will write down lambda into G. This is the answer to this question. Okay, simply यहाँ पे मैंने क्या put किया? I have put this K is equal to mu naught divided by 4 pi, and what I have done is that this mass per unit length is equal to lambda, because mass is not given to me, lambda is given to me. Let's move to question number 2. देखें बेटा question number 2 क्या है? Question number 2 has been asked from kinetic theory of gases and is comparatively an easier question. Okay, it is not that difficult question. तो देख ले बेटा आप क्वेश्चन में क्या दिया गया. 1 mole of monoatomic gas undergoes adiabatic expansion. Temperature decreases from 60 Kelvin to 50 Kelvin. Calculate the work done. We are supposed to calculate the work done. Okay, so first and foremost we should know what is the equation, what is the exact equation for the work done for an adiabatic process. Work done for an adiabatic process is something like this, that is N into R divided by gamma minus 1, where gamma is called as the ratio of specific heats, or it's called as adiabatic factor, multiplied by T1 minus T2. Now let's try to put the values here. So it will be equal to N is 1 mole, then R is given to you, it is 8.3, divided by gamma minus 1, that is 5 divided by 3 minus 1, multiplied by T1 minus T2. T1 is 60 minus 50, 60 minus 50. So this is 8.3 divided by 5 minus 5 by 3 minus 1 is 2 divided by 3. 2 divided by 3. Let me write down here 2 divided by 3, this here multiplied by 10. So eventually it is going to be 8.3 into 10 by 2 is 5 into 3. Okay, so which is what? This is 8.3 multiplied by 15. Now 15 into 8 is 120, so it will be somewhere between 124, which is the only option we have there, 124 point something. So this is the approximate answer to this question. Okay, यहाँ पे आप एक काम और भी कर सकते हैं कि when you arrived at this very point, so then look at the options, then make an educated guess what can be the answer, what can be the close answer here. Okay, calculation करने की कोई ज़रूरत नहीं है further. Question number 3, a very easy question, direct question. It is from the Rutherford's model of atom. तो question ये है कि plot n of theta, that's the number of alpha particles that scatter by angle theta versus theta graph. Okay, 4 different graphs are given to you and you should know this graph. It is very easy question, easy peasy question. So it is simply like this. दिस ईयर एंगल थीटा एंड दिस ईयर एन ऑफ थीटा. स्कैटरिंग फार्मूला अगर आपको याद होगा, स्कैटरिंग फार्मूला एन ऑफ थीटा इज प्रोपोर्शनल टू 1 by sin raised power 4 theta divided by 2, which means that the graph will look like this is the graph of this. Okay, somewhat rectangular hyperbola. It's not rectangular hyperbola, but somewhat you can say it's like a rectangular hyperbola. Let's move to another question. Again, an easy question. It is not a difficult question. It's a doable question. Okay, so question is simply like this, that this is a car is moving on a circular path. Car is moving on a circular path. Moving on a circular path. Circular path. Now, what is given in the question? To be exact, what is given in the question? The radius is given. The maximum velocity is given. See that the radius of the circular path is given. The velocity is given, safe velocity. Acceleration due to gravity is given to you, 10 meter per second square. What we are supposed to calculate is angle of banking. So it's a very easy question. You should know the equation for the angle of banking, that is tan theta equals to v square divided by rg. Okay, now what is the velocity? That is 10 square comes out to be 100 divided by radius is given, that's equal to 50. Acceleration due to gravity, you know that is 10. Now 100 and 100 will cancel, it is 1 divided by 5, which implies the angle of banking theta will be equal to somewhat like this, tan inverse of 1 by 5. So this is the answer to this question. So again, an easy question. Okay, let's move ahead. Have a look at the question number 5. Question number 5 is again an easy question. It is on EM waves. Question is based on EM waves, and easily we can do this question. There's no doubt about this. Okay, see that first and foremost what is given is that microwaves are given, then UV rays, then gamma rays, and radio waves. All right, so आपको ये देखना बेटा, you will have to match the column, then applications are given to you. See that microwave one, you know that microwave one. So it simply implies that the microwaves are used to warm the food, as simple as that. Then you know the UV filter as well. So UV rays are used to kill the germs and hence purify the water. Then you know the radio waves, they are used for the radio communication, that is AM and FM communication. Then the gamma, it is used to treat the cancer. So very simple question. It is really not a rocket science. Easily we can do this question. So that means this P matches with what? P matches with the second, Q matches with the first, R matches with the fourth, and the S matches with the third. Okay, so let's shift to another question. So this is the answer to this question. Let's shift to another question. This one slightly difficult, I can say, but not undoable. You can do this question very easily. Okay, so what is the question? The question is like this, that there is a polyatomic gas. It has 3 translational degrees of freedom, 3 rotational, that implies it is polyatomic non-linear, and it has also some vibrational degrees of freedom, F. If Cp by Cv, which implies the gamma, is given to you, that's 8 by 7, you are supposed to calculate what is the number of vibrational degrees of freedom. Have a look. What is the equation between gamma and F? Equation is something like this. It is 1 plus 2 divided by F, where F is the degrees of freedom. Is that clear? Okay, tell me what is the value of this gamma that is given to you, that is 8 divided by 7. Then here I will write on -1 equals to 2 divided by F. What about the degrees of freedom? The degrees of freedom are simply like this. It is 2 divided by, there are 3 translational degrees of freedom, plus there are 3 rotational degrees of freedom, plus have a look, concentrate on this. There are F vibrational degrees of freedom. When there are F vibrational degrees of freedom, we write here 2 times F. All right. Okay, now let's try to solve the simple equation and we will try to calculate the value of this F. 8 by 7 minus 1 will be simply equal to 1 by 7 equals to 2 divided by 3 plus 3 is equal to 6 plus 2F. Okay, which implies 6 plus 2F becomes equal to 14. So 2F becomes equal to 14 minus 6 is 8, which simply implies that the number of degrees of freedom, vibrational degrees of freedom, will come out to be 4. So this is the answer to this question. So not that undoable. I'm sure you had done this question very easily. Let's move to question number 7. Question number 7 thoda sa hai, I can say that it is a bit difficult. It is more than a moderate question. Okay, the question has been asked from the chapter that's electrostatics, one of the important chapters for NEET and JEE. Okay, now what's the question? The question is simply like this, that this first of all given a solid sphere, a solid insulated sphere is given whose charge is equal to capital Q, radius is capital R. Then at a distance of small r equal to 3r, that means outside, a charged particle is placed. This is the charged particle placed whose charge is negative, that's minus q, and the mass is equal to m. Is that clear? Okay, then obviously this negatively charged particle will be attracted by this positively charged sphere, so it will accelerate towards the sphere. The question is calculate the velocity on the sphere. Calculate the velocity on the sphere. See, you cannot apply here equations of motion. Why? The reason is that as the charged particle moves from this point to this point, the electric field will not remain same. Electric force on the charged particle will not remain same. Hence, acceleration is not constant. When acceleration is not constant, we cannot apply equations of motion. Then what else we can do? We can simply apply energy conservation. Now, what does that mean? That means the initial mechanical equals to final mechanical, which means K1 plus U1 equals to K2 plus U2. Now, what's initial kinetic? That is 0 because the particle starts from rest. Potential energy is always equal to Q into V. Charge multiplied with the potential. So this implies this will be minus Q into V1 because the charged particle is a negatively charged particle. Kinetic energy final will be 1/2 of mv square. Potential initial final will be minus Q into V2. While this our point number 2 on the surface, and this our point number 1 somewhere here at r equal to 3r. Okay, now bring it here. So this will be Q multiplied by V2 minus V1. 2 will be here divided by mass. This will be the velocity square. All right, now eventually let's try to solve this. So the velocity will come out to be what it will come out to be. Okay, तो यहाँ पे जो आएगा बेटा, I will write down here 2ice q divided by m, velocity square here 2ice q divided by m. What is the potential due to the solid sphere? Potential at this very point, at this point, the potential which is V2 is equal to, because of the sphere, is kq divided by r, isn't it? And what about the potential at this point? The potential is simply that is kq divided by 3r. Okay, so V2 minus V1 will be something like this. It will be, what is V2? That is kq divided by r minus kq divided by 3 into r. So the velocity comes out to be, it is twice k small q capital Q divided by m into capital R. Then 1 minus 1 by 3 is 2 divided by 3. Okay, now finally it comes out to be 2 into 2 is 4 divided by 3 into mr. This k will be replaced by 1 by 4 by epsilon naught. It is electrostatic constant. What's it equal to? 1 by 4 pi epsilon naught. Then it is capital Q small q. Okay, then what will cancel is this 4 and 4, and eventually this is the answer to this question, that is velocity is equal to square root of what? Capital Q small q divided by 3 pi epsilon naught into m into capital R. This is the answer to this question. Okay, question demands a bit of calculation, no doubt about that, but I will not say that this question is undoable. थोड़ा सा यहाँ पे आपको दिमाग लगाना था, so easily this question can be done. Okay, question number 8, I can say that this question is difficult. There is no doubt about that. Okay, now the value of alpha, beta and gamma are given here. Okay, let's switch to another question. Right now I don't know the value of this alpha, beta and gamma. Okay, so what makes this question difficult is that we are not supposed to calculate average speed. We are not supposed to calculate average velocity. We have to calculate average speed, which makes this question difficult. Point number 1. Point number 2 is that the velocity, you will see that at some point of time the particle returns back, and you know that whenever particle returns back, it changes its direction. Average speed will not be equal to average velocity. Okay, so let me first of all do one thing, that is I will write down what is this displacement of the particle equal to, that is t square minus beta is 6, तो ये बन जाएगा बेटा 6t plus this is 5. Okay, in this very sort of question what you do first of all is that, first of all, let's suppose that this t equal to 0. Let's try to see t equal to 0, what is the position of this particle? Obviously that is 0 0, and here it is 5, so it is 5 meters. All right, at t equal to 0. And tell me one thing, at t equal to 6 seconds, what will be the position of this? Position will be again equal to, it is 6 square minus 6 into 6 plus 5, that is 36 minus 36 will cancel, it is 5 meters. Okay, if we'll directly calculate average velocity, that is 5 minus 5 divided by 6 minus 0, which is 0, which is 0. Option है वहाँ पे 0, but that is not the answer to this question, because we are not supposed to calculate average. Its average velocity is 0, average speed will not be equal to 0. Okay, now what I will try to do is that, let me find the velocity of the particle. What is the velocity of the particle? The velocity of particle on differentiating will be 2t minus 6 equal to 0. ये मैंने 0 equate क्यों किया? Because I want to see at what time the particle changes the direction. So 2t is equal to 6, which implies t is equal to 3 seconds. This t equal to 3 seconds, I say it is the turning point. Turning point implies that it is that time when the particle changes direction. And whenever the particle changes direction, at that point of time, at that instant, the velocity becomes equal to what? 0. Okay, now let me see at t equal to 3 seconds, where is the particle? At t equal to 3 seconds, what is the position of the particle? Okay, let's put it here. So it will be 3 square minus 6 into 3 plus 5. I will say that this is an unlike Neet question. Such type of questions are not asked in the Neet. For the first time, this type of question has been asked in Neet. 3 square is 9, 6 3 18, 9 minus 18 is minus 9 plus 5 is, this is minus 4 meters. Okay, so next what I'm going to do is that, let me trace a path for this. Okay, tell me one thing, initially why the particle lies? It lies at s equal to 5. So this is s equal to 5 meters and t is equal to 0. Let's suppose this is point A. Okay, at t equal to 6 seconds, where does the particle lie? So t equal to 6 seconds, particle again lies here. Okay, tell us one thing, at what time the particle returns its position? It turns its position at t equal to 3 seconds. Okay, so that means the particle is moving in this direction, and at t equal to 3 seconds, this is for example this s equal to 0 meter implies the origin. Okay, so this is s equal to minus 4 meters at the time that is equal to what? 3 seconds. Okay, now what does that exactly imply? It implies that पहले जो ये particle है, it starts its journey from the point A, goes to the point B, like this. It starts its journey from the point A, goes towards point B, and then goes from the point B to the point A. Okay, hence displacement is equal to 0, average velocity will be equal to 0, but the distance and the average speed will not be equal to 0. Can we calculate the distance? Yes, of course. Now we can calculate the distance. The distance is simply equal to, what's the length of this? That is, this here 5 meters, so that implies this length is 5 meters from here to here. And what about this length? This length is equal to 4 meters from here to here, isn't it? Okay, so the total distance will be 5 plus 4 multiplied by 2, because it goes from point A to point B and then goes back to the point A, which comes out to be exactly 18 meters. And what's the time taken during all this? That is 6 seconds, which is given in the question, and you are in search of average speed. So average speed comes out to be 18 divided by 6 is equal to 3 meter per second. ज़्यादातर स्टूडेंट्स ने इसका आंसर निकाला होगा, 0 ऑप्शन था वहाँ पे, that was a trap. Okay, but the answer is not 0, it is 3 meter per second. Okay, let's move to the question number 9. Can we say this question is a difficult? No, not at all. It's not a difficult question. थोड़ा सा आपको यहाँ पे दिमाग लगाना था, कोई कैलकुलेशन की ज़रूरत है ही नहीं. अदरवाइज नॉर्मली यहाँ पे कैलकुलेशन वाला क्वेश्चन आता है इसमें. दिस इज सेमीकंडक्टर क्वेश्चन, ठीक है ना, दिस इज फ्रॉम सेमीकंडक्टर्स. Okay, but the question is conceptual, it's purely theoretical question. Have a look. फर्स्ट एंड फॉरमोस्ट देयर आर 3 डिफरेंट डायोड्स। ये वाला क्वेश्चन तो आता ही आता है, लेकिन वहाँ पे जो पूछा जाता है दैट इज कैलकुलेट द करंट दैट इज सेंट बाय द बैटरी, ओके, और व्हाट्स द करंट फ्लोइंग थ्रू दिस रेजिस्टेंस एंड दैट रेजिस्टेंस। लेकिन यहाँ पे क्वेश्चन कुछ और पूछा गया है। क्वेश्चन है द फर्स्ट थिंग आई विल टेल यू इज दैट दिस इज पॉजिटिव नेगेटिव विच implies that this diode is reverse biased, this one is forward biased, and this one is forward biased. Now have a look. The question is that it's not difficult question but an unexpected question. If W1, W2, W3 are the widths of the depletion regions of diodes D1, D2 and D3, then you will have to tell in which diode the depletion width of depletion region will be larger. So conceptual question. तो आपको सबसे पहले ये आइडिया आना चाहिए कि जो width of depletion region है that increases when the diode is reverse biased and it decreases when the diode is forward biased. And then the width of depletion region does not only depend upon the forward biasing and reverse biasing, it also depends upon the magnitude of doping, which we don't know. But one thing is for sure, that is we know that this D3 will be maximum. D3 is maximum. That's for sure. We know that D3 is maximum. Out of D1, D2, the depletion region length will be less, but we cannot compare them. We don't know that. Okay. Now have a look at the options. Do we get a clue from the options? तो ऑप्शन नंबर पहला तो ये है W3 is equal W2, which is impossible. ऑप्शन नंबर सी आप देख ले, अगेन इट्स इम्पॉसिबल. ऑप्शन नंबर सी डी तो पॉसिबल ही नहीं है बिकॉज W3 इज मैक्सिमम. अगर आप ऑप्शंस की तरफ देखोगे, only the option number B is there which can satisfy that condition that this W3 is maximum. So this is the correct answer to this. It was very conceptual question. थोड़ा सा आपको दिमाग लगाना था, तो easily you could have done this question. Let's move ahead. Let's move to question number 10. Question number 10 sort of calculation, but not that difficult. Have a look. You are supposed to calculate the maximum current. Okay, simply what you have to do is that you will have to use a law that's called as the Ohm's law. Have a look. मैक्सिमम करंट आपको कैलकुलेट करना है. सो मैक्सिमम करंट जो LCR सर्किट में होता है वो होता है V नॉट मैक्सिमम वैल्यू ऑफ वोल्टेज डिवाइडेड बाय Z ऑफ सर्किट. Z इज कॉल्ड एज द इम्पिडेंस. ओके, दिस आवर LCR सर्किट. फॉर एग्जांपल दिस हियर L एंड दिस C एंड दिस R. अगर आपको याद होगा दिस XL जो होता है इट्स इक्वल टू L ओमेगा. दिस इज रेजिस्टेंस एंड XC इज इक्वल टू 1 डिवाइडेड बाय C ओमेगा. ओके. Now what about the Z? Z is exactly equal to square root of XL minus XC whole square plus R square. Now omega is given to you. This is omega. This is the value of omega. This is the value of omega. This is the value of omega 2 into 10 is what, because the sine omega t. So omega is, let me write on the values here. The omega is given, that is 2 into 10 to the power 3. That L is given, that C is given. What's the value of L? L is given to you, that is equal to 10 millihenry, which implies it is 10 to the power minus 2. Then capacitance 20 microfarad. C is given, that's equal to 25 micro implies 25 into 10 to the power minus 6. And the resistance is also given to you, that is 100, 10 to the power 2. Okay, you put these values here in this equation, you will exactly get the Z equal to 100 ohm. Exactly, you will get the Z equal to 100 ohm. Now can we calculate the maximum value of the current? Yes, of course we can calculate. I naught is equal to V naught divided by Z. Now what's this V naught? V naught is the maximum value of the voltage, which is this 220 volt, the coefficient of the Z. Okay, now let's put these two values. So here it is 220, okay, divided by 100. This will demand a bit of calculation. Divided by 100, so it comes out to be 2.2 ampere. This is the answer to this question. Okay, again not that difficult question. I will rank it as somewhere between the moderate and the difficult. Okay, so question number 11 is a difficult question, no doubt about that, because again the Neet has never asked this type of question. लेकिन अगर आप थोड़ा सा ध्यान रखोगे तो उतना भी अनडुएबल नहीं है, और आपने करे हैं इस तरह के क्वेश्चंस. ठीक है ना. अब देख लें बेटा. So what's the question? The question is simply like this, that a particle moves from x equal to 0 to x equal to L. Okay, coefficient of friction is variable. This is, you are seeing this for the first time. At x equal to L, the coefficient of friction becomes equal to 0. Calculate the work done by the friction. Normally जो friction होता है that is a constant force, because the coefficient of friction is a constant. but it's something like this, it is something like this. Have a look, ये हॉरिजेंटल सरफेस आपके पास है बेटा, तो ये है आपके पास एक ब्लॉक, ठीक है जी। इस ब्लॉक का मास मान लीजिए फॉर एग्जांपल दैट इज इक्वल टू m, ओके ऑल राइट। इट इज मूविंग इन दिस डायरेक्शन फ्रॉम वायर टू वायर, इट इज मूविंग फ्रॉम x equal to 0 to x equal to l, x equal to l, all right, okay। then at x equal to l again the coefficient of friction becomes equal to 0, तो यहाँ से coefficient of friction फिर से किसके बराबर बनेगा, 0 के बराबर, ठीक है जी। तो आपको कैलकुलेट क्या करना है, यू विल हैव टू कैलकुलेट द वर्क डन विद द फ्रिक्शन। देख लो ऊपर की दिशा में इन द वर्टिकली अपवर्ड डायरेक्शन देयर इज नॉर्मल, इन द डाउनवर्ड देयर इज mg, इन द बैकवर्ड डायरेक्शन देयर इज फ्रिक्शन, definition is mu multiplied by n, isn't it? So can I write down the friction? Of course I can write down it, it's equal to mu into m multiplied by g, okay। नॉर्मली होता है ये म्यू कांस्टेंट, लेकिन यहाँ पे दिया गया है एज अ फंक्शन ऑफ एक्स। व्हाट इज इट एग्जैक्टली, इट इज म्यू नॉट माइनस अल्फा इंटू एक्स multiplied by what, multiplied by m into g, and this force is it a constant force or a variable force, a variable force। फिर आपने वर्क पावर एनर्जी में अच्छे से पढ़ा होगा, पहला ही टॉपिक है वर्क डन बाय द कांस्टेंट एंड वेरिएबल फोर्सेस, एंड दिस वेरिएबल फोर्स, नो डाउट अबाउट दैट, ओके। लेट्स डू वन थिंग, दैट इज विल हैव टू कैलकुलेट द वैल्यू ऑफ दिस अल्फा। वो हम कैसे कैलकुलेट करेंगे देख लें आप बेटा, okay। Let's first of all solve this। so you want to calculate the work done, work done will be equal to integration of f dx, so work done is equal to, this is here mg is a constant, multiplied by integration of this will be mu naught into x, minus integration of this will be alpha square divided by 2, and the limits of integration are from 0 to l, all right। so the work done comes out to be mg, lower limit is 0, so it will be mu naught into l minus alpha into l square divided by 2, all right। this is the answer, but there is a condition which is given in the question। वो condition क्या है, what is that condition? condition is that हमारे पास जो friction है that is mu is equal to mu naught minus x multiplied by l, x multiplied by alpha multiplied by x, alpha multiplied by x, here it's alpha multiplied by x, is equal to 0, is equal to 0 at x equal to l। so let's put the value of x here, so it will be mu naught minus alpha into l is equal to 0, which implies that alpha is equal to mu naught divided by l, okay। let's put it here, so the work eventually becomes mg multiplied by mu naught into l minus, what is this alpha, it is mu naught divided by l into l square divided by 2, this l and this l cancels, now 1 times mu naught l minus half times mu naught l becomes finally equal to mg into mu naught l divided by 2, this is the answer to this question। was it like a neat question? No, never at all, I can say that it's a difficult question। this is very easy question, this is never a difficult question, a very easy question। the question here beta, there are two gases which are given to you, gas A and gas B, then it is given that the mean free path of the gas is equal to half of the mean free path of the gas B, and the diameter of the molecule of gas A is twice that of the gas B, and Na and Nb are the number densities of those two gases। what we are supposed to calculate, we will have to calculate the ratio of the two, that is calculate Na is to Nb, this is what we have to calculate, all right। so let's try to calculate this, okay। the equation for the lambda is this is what we call as mean free path। now have a look from this equation, we can easily say that this n is proportional to 1 divided by lambda into d square। what we have to calculate is Na divided by Nb, it will be equal to lambda b divided by lambda a multiplied by db divided by da whole square, isn't it? okay, let's put the values here। बताइए आप मुझे lambda a किसके बराबर है, that is lambda b divided by 2, which means that lambda b divided by lambda a is 2, so this is simply 2, multiplied by db divided by da is equal to 1 by 2, so this is 1 by 2 whole square, 2 and 2 will cancel, so it comes out to be 1 by 2, which implies that Na is to Nb will be equal to 1 is to 2, okay, all right। let's move to another question, question number 13। is this question number 13 easy question or it is difficult question? it is very easy question, okay। आराम से हम कर सकते हैं बेटा। ये यहाँ पे देखिए आप, so there are two configurations, configuration P and the configuration Q, all right। these are two solenoids, First, they are connected in series and then they are connected in parallels. Now the question is that the induced EMF between these 2 points, between the point A and the point B, here it's point A and here it's point B, that is induced EMFs EP and EQ in the two configurations that is given to us, EP and EQ. What we are supposed to calculate is the ratio of EP and EQ. Okay, so how can we do that? Easily we can do that. Induced EMF होता है बेटा minus L into DI divided by DT, which implies is directly proportional to L. Okay, while L is the self inductance of these inductors. Now tell me one thing, what is this LP equal to? Since we are supposed to calculate induced EMF only between A and B, so that means LP will be equal to L. And what about this LQ in the second configuration? These two are connected in parallels. When they are connected parallels and they are identical, so it will be simply equal to L divided by 2. L divided by 2, which implies that EP divided by EQ will be equal to L divided by L by 2. It comes out to be 2. So the answer is EP is to EQ is equal to 2 is to 1. This is the answer to this question. तो आगे चलते हैं बेटा, क्वेश्चन नंबर 14 देख लें आप. Question number 14 is based on the waves. Let's try to crack this question. First and foremost, what is given is that the sound waves number of modes for the fifth harmonic of an open-ended pipe is n. Open-ended pipe. So for the open-ended pipe, this n is simply equal to 5. Straight away it is equal to 5. All right. Then it is given that जो दूसरी pipe है बेटा वो है one and closed. One and closed is m and there's ninth harmonic. Okay, so the number of nodes you will calculate for the m will be equal to, that is 9 plus 1 divided by 2. This is the formula. If there's open-ended pipe, then it will be directly equal to this. Fifth harmonic is, so number of nodes will be 5. If one is closed, then it is n plus 1 divided by 2, which is equal to 5, which implies that n divided by m will be simply equal to 5 by 5, which is 1. As simple as that. Okay. Next question, question number 15. Again a direct question. What is the self-inductance of this solenoid? Which you are supposed to memorize directly. तो इसका जो आंसर है बेटा वो ये है mu naught n square into A into L, where this A is the area of cross section of this cylinder, that is pi r square. और इसका जो होता है self-inductance, that is this mu naught n square into A into L. Okay, let me stop here at the question number 15. I will upload 2 more videos for another 30 questions. Okay, see you next time.